Good day, class. By now you've probably discovered that I will not be in today. Please do and be on your best behavior for the substitute today. Today you'll be receiving your instruction via this video, and the expectation is that you pay attention to the instruction, take notes, and at the end of the instruction complete the assignment that I have for you today. You should have picked up this paper off the back table when you first came in. The homework that is due today, I would like for you guys to hold on to that, and I will collect it from you tomorrow. You may be able to use some of the information from that homework assignment to assist you in today's assignment. You'll notice that on today's paper, the questions that I have for you are the same as the questions we've been working on for the last couple of days. The only difference with today is we are introducing a new way of using this information, and by creating a graph and finding the appropriate domain and range for these given scenarios. Okay, so you'll notice in the instructions at the top, it asks for us to label the axis, and that's going to be both the x and y axis, identify the intercepts, both x and y intercepts, and determine the appropriate domain and range for the given scenario. Now, I'll be the first to admit, domain and range is a little bit tricky when it comes to this. Some will be easier than others, but you may have to give it some real thought to decide what's the most fitting domain or fitting range for the given scenario. I'm going to work number 1 with you guys, as this is actually one of the trickier ones out of the 10 problems. You'll see why here in just a moment. So if you recall in this story, you got Jordan who's trying to save some money for college. He has saved up $10,000, and he's currently attending a college where he's staying in an apartment with a rent of $450 each month. And so if we were to try to graph this, we would have a few different options. It's already pretty much in slope-intercept form, so we could graph it using the y-intercept and its slope. We of course could go to the calculator and graph it on the calculator and try to transfer the graph onto the paper. And then the final option, we could change this into standard form, and then from standard form find our x and y intercept to help us create the graph. Okay. The benefit of changing to standard form and finding your x and y intercept is it generally will tell you the highest and lowest points of your graph. And so that can be real helpful when you're trying to determine how to label or how to scale your x and y axis to make sure that you include all the data as it pertains to that equation. So I'm going to actually start with that on this problem. We're going to change this over to standard form. So seeing how there's no fractions here in this problem, it's only going to be one step to get it to standard form. Which is simply to add the 450x to both sides of our equation. Alright, and so when we do that, our new equation will be 450x plus y is equal to 10,000. Okay. And so now we have it in standard form. This makes it much easier to find our x and y intercept. Now remember, to find your x-intercept, you simply cover up, you put a 0 in for the y, right? So if you're putting a 0 in for the y, that's basically covering up the y. And so now you have 450x equals 10,000. And so to get your x-intercept, you need to divide by 450. And so we end up with 10,000 divided by 450. And so that would give us an x-intercept of 22.2 repeating. Okay, you can do the same trick for the y-intercept. Put 0 in for the x, which if you do that, that removes the x term. And so you end up with just y equals 10,000. So our y-intercept here is 10,000. Okay. Alright, So we have an x-intercept, we have a y-intercept. That kind of gives us our highest y value we're going to use for this graph, and it will also give us the highest x value we'll be using for this particular graph. Now please understand that not all equations, linear equations, will have both an x and a y-intercept that makes sense for the given scenario. So you're really going to have to kind of think about the values you got for your x and y-intercept and decide, is that part of the graph that I really need or not? For this one, it is pretty appropriate though. If you recall, our x in this story was the number of months that we rented the apartment, and our y in this story was the amount left in our savings, so our savings balance. And so if we think about that on our graph here, for the x-axis, I'm going to label the x-axis as time, but I'm going to be specific here and list the units as months. So it is time, but specifically it's going in months. And then over here we're going to say that this is our savings balance. And this is where keeping your homework from yesterday could help you out. It might help you remember what's x and what's y for each of these scenarios. So for this one is our savings balance, and that's going to be in dollars. Okay. Excuse me. Alright, so at this point we need to come up with an appropriate scale in order to make this graph. Well, we know that the y value, the highest it's going to reach, is 10,000. So we don't need to make each marking count by ones. That would be kind of ridiculous for going to 10,000. So we would want to pick something that would get us to 10,000 in a relatively short amount of time. Alright, and so also keep in mind you don't have to actually write down a physical number on each of these little bitty hash marks. It would probably be a little too crowded and too difficult to read if we did that. So you can go every other hash mark and just make it count by a certain increment. I think for this one it might be appropriate to go every other hash mark and maybe count by thousands. That would get us to 10,000 relatively quickly, and we would just go every other mark here, so 0 being at the origin at the bottom here. So the first mark's 500, the second mark would be 1,000. So then I skip another mark, and the next mark would be 2,000. Then we skip a mark, and the next one would be 3,000. Skip a mark, and 4,000. So you're really counting by 500s if you think about it, but since we're skipping marks, it just makes it a little bit easier to get this labeled on our graph. So there's 5, 6, 7, 8, 9, and 10. Alright, and so now there are some leftover marks, and we could keep going. We could put 11,000 up here, but it's just not necessary since we're only going up to 10,000, so we're going to stop there. Alright, now the x-axis being in months, we know that the highest number of months we would necessarily need for this graph is 22. So if I go out to 23, I should be fine. I should be able to cover everything. Now, once again, you kind of look at your markings to decide what to count by. This one has enough marks you could count by ones if you wanted to label every single mark. I don't necessarily want to do that, but I'm still going to count by ones. Instead of labeling every mark though, I'm just going to go every other mark. And so we'll say 1, 2, skip 1, 3, 4, skip 1, 6, skip 1, 8, 10, 12, 14, 16, 18, 20, 22. So that last little mark there would be 23. Alright, and so the key to having a quality labeled axis is to make it easily readable. Make sure you're staying with equal size increments. You don't want to change in the middle, go from counting by 2s to all of a sudden count by 4s or 5s or something. Stay with the same increment all the way down the axis. Alright, so now we're ready to graph this. So we know our graph would start out up here at 10,000 in the beginning before he started college, because that's what he saved up. Alright, now In some cases, we can use our x-intercept, find it on the graph, place a point there. In this case, 22.2, place the point there, and then just simply connect the line to our 2 points. But we have to decide, is that appropriate for this given scenario? Remember, your graph needs to represent the problem. Well, that wouldn't really make much sense for this particular problem. Because with this problem, we're saying that each month the amount in your savings account is dropping by $450. And so it doesn't really include the amount in the savings in between months. In other words, we're not going to say, okay, well, it's January 14th, so I want 14 days worth of rent. No, you're going to wait till the end of the month, and you're going to get the full month of January's rent, right? The whole $450. So for this one, instead of making a solid line, what we're actually going to do is we're going to start at 10,000 and count down by 450 for each month. Now, that would take a while if you want to do all 22 of these little dots. You could do it. It'll just take a while to get all 22 dots. I'm okay if you just want to go every 2 months and put where the point would go. So instead of going down by 450, you'd actually go down by 900 because you're going every 2 months. For me, that would be a little easier to graph, take a little less time. Okay, but the idea is I just want you to understand that you're putting individual points down instead of a nice solid line, because we're not dealing with in-between days of the month. Now use your calculator to assist you in this, okay? You've got your TI calculator. You can, I don't know how well you can see that on the screen, but it's just an image of the TI calculator. Remember, you can go to y equals, and you can type in your equation there, 10,000 minus 450x, and then do second graph to come up with your table. And so I'm going to see if I can zoom in on that a little bit. See if it'll focus. There we go. Alright, so there's our table, and so now if I was doing every other month, I would just go 0, 2, 4, 6, 8 on the x's and put a point at wherever the y values are for those. And so I'm going to do that real quick on here. I'm just use my table here. So at 2 months, it's supposed to be at 9,100. Now again, this may not be exact. You know, it's a little bit above 9,000, not quite 9,500. So kind of somewhere in there. Alright, now we got at 4 months, it's 8,200. So that's going to be probably right in there somewhere. Alright, doesn't hurt to have a straight edge when you're doing this, to just kind of line up so you can make sure it's above where it's supposed to be. At 4, so that was at 4, now we're at 6, so 6 is 7,300. Okay, and then we go to 8, and so 8 is at 6,400. Okay, and then 10 is at 5,500. And so you guys get the idea. So you're making these individual points. Notice I'm not connecting the points. I'm just going to keep going till we run out of money in the savings account. So I'm going to scroll down on my table here a little bit. Because I'm kind of running out of values here. Alright, so at 12 we got 4,600. Um, 14, 3,700. And 16 is 2,800. Again, these are all just coming straight off the table. And 18 is at 1,900. 20 is at 1,000. Alright, and then 22 was at 100. Mine's getting slightly off. Alright, and so then anything past 22, there wasn't enough money to pay the rent, right? So you wouldn't be plotting any more points because that would now put you into the negative balance. So this is where the graph would start. So when you're making your domain range, if you're making individual points, it's best to just create a list to represent those values. Remember, domain is your x values, okay? So this is x values. And range is the y values. Okay? And so for our x values, basically it's going to be everything from 0 to 22. Alright, so you can list out 0, 1, 2, 3, 4 until you get to 22. That would be perfectly appropriate and suitable for this particular problem. I will, however, show you a little bit of a shorthand way to write it, so you don't have to write quite so much. We can say that x is everything from 0, y'all remember doing this, the interval notation, from 0 to 22, with the clause of only whole numbers. So in other words, we're not going to be including like x is 1.3 or x is 20.4. Those aren't going to be included. It's just going to be 0, 1, 2, 3, 4, 5, 6 till you get to 22. So that's a suitable way to write it as well if you don't want to have to sit there and list out the numbers 0 through 22. Now your range would work the same way. It would also typically be a list of dollar amounts that are suitable for this situation. And so it would start at 100 and go up to 550 and then up to 1,000 and then 1450. So you would be listing all the values starting at 100, adding 450 each time. So again, you can make that list. It would be simple. It would just come off your table, off your calculator. But a short way to write it, so you're not going to write so much, is you would say y is everything greater than or equal to 100, but less than or equal to 10,000. And again, you want to specify, so you would say in increments of $450. Okay, meaning that it's counting by, from 100, counting by 450s all the way up to 10,000. Okay, so both of those would be acceptable whether you wrote the list out or if you just wrote it like this. It's kind of a short way to write it. Alright, so that concludes the first problem. Let's look at another one here. I want to skip to number 5. This is the one with annual salary. Get that a little bit more on your screen. So on question 5, with the annual salary of $32,500, she makes 20% of commission on her sales. So this is one of those where if you change it to standard form by subtracting the 0.20x on each side, so now you wind up with minus 0.20x plus y equals 32,500. Well, when you go to find the x-intercept, meaning you cover up the y, you're going to divide by negative 0.20. So if I go to my calculator here and I do 32,500 divided by negative 0.20, I get an x-intercept of, let me just write it over here, an x-intercept of negative 162,500. So it would not make any sense to want to graph that, because that's going to be graphed way out here somewhere to the left of our graph at negative 162,500. It doesn't really have any value or any meaning to this particular story, so I'm actually not going to use the x-intercept. But I am still going to use the y-intercept. Notice if I cover up the x, it says y equals 32,500. So that y-intercept has some meaning to me. That's going to help me with my graph, because that tells me my graph should start at that value, and from there it's going to go up. So this is actually going to be my lowest y value. Alright, and so if that's my lowest y value, I got to think about, okay, well, how am I going to scale this to make that make sense? So first let's label our x and y axis. Remember from this one, x was the amount of sales. And again, that's going to be in dollars. So our units here will be dollars. And our y was our total salary, right? It was our That's our annual salary. Well, I want to say salary because salary is technically this 32,500. You could say it's our annual income. How's that? Our annual income. Again, that's going to be in dollar amounts. Alright, so if I want a graph to start at 32,500, I don't want to start counting down here by something small and then wind up at 32,500 at the top of my graph, especially since my graph's going to only continue to go up from that number. That wouldn't make a lot of sense, would it? So ideally, you want your 32,500 to be somewhere down here and then allow for the graph to increase from there so you could get a better representation of the scenario. So there's a couple of tricks to this. You could find a larger thing to count by so that you get there very quickly, but that might squish down your graph quite a bit when you go to graph it. The other option is you can actually put, it's kind of looks like a squiggly line, okay? It's kind of zigzag, if you will, kind of like a zigzag line down here by the origin. And so basically when you put that zigzag line in, it lets you start the first mark at whatever number you want. So I might start my first mark here at 32,500. Okay, so that's what the little zigzag line does. And then you can count up, make each one whatever value you want. So if I want to go by $500, I can do that. So the next one would be 33,000 and 33,500, so on and so on. You can count by whatever you want, just keep it that same increment all the way up. So if I go every other line, so I don't have to write so much, if each one's worth 500, every other line would be worth 1,000. So I can make this one 33,500, skip a line, make this one 34,500, skip a line, make this one 35,500. Okay, you get the idea. So I'm just going to stop. I'm going to stop here at 37,500. I could continue on up the rest, but you kind of get the idea. Just going up 1,000 every other line. Then on the amount of cells, again, trying to be realistic here, you're getting 20% of your cells. You know, your cells, probably whatever you're selling is quite valuable. You're selling either very expensive appliances, electronics, possibly cars or homes. So your sales could be just about anything. Just because we don't have enough information here to know what she's selling, it does make it hard to figure out what you want to count by on the sales. So I would really accept pretty much anything you want to count by here, you know, that's appropriate here. So if we want to assume she's selling things that might cost, you know, $1,000 amounts, we could have this be 0. Have the first line be 1,000, or skip a line, have the second line be 1,000, skip a line, have the next one be 2,000, skip a line 3,000, and so on and so on. So that could be her sales. Alright, and so you can use that now to figure out, alright, well, if you sold nothing, you would have $32,500. But if I sold $1,000, I would get 20% of that. So I would get basically $200, and so I could add $200 to my $32,500, so I'd now be at $32,700. And so that's going to be kind of between here and here. It's going to be something like that. And then if I sold $2,000, well, if I got $200 for selling $1,000, it would make sense, and I would get $400 for selling $2,000. And so that would take me almost up to the next line. And so you would figure out pretty quickly every $1,000 I'm going up another $200. And so you could kind of continue your graph out that way. Alright, now in this particular scenario, you could sell things that, you know, sell for decimal amounts. In other words, what I'm saying is you could sell an item that cost $1,250.26. So you would get commission based on that, right? So it could include decimals in this one. So this is a situation where even though I'm counting by thousands, I could sell something that falls in between those markings. So this is actually a scenario where once you make enough points, you would actually make a solid line connecting those points. Okay, so you don't want to make several points so you can kind of see where that line goes, but the idea is this one would be a solid line because it does include all these possible sales dollar amounts in between the ones I've got listed here. Alright, so now quickly to discuss our domain and range. Domain being the X values, being the amount of sales, there's really no limit on the amount of sales. It's just however good you are at selling stuff, you could keep selling and hit whatever dollar amount you possibly could reach. Now there is a lower limit, it can't go past 0, so we would just say that X is pretty much anything greater than or equal to 0 for the sales. And then for our range, well, the lowest amount that I could possibly make if I don't sell anything is the $32,500, right? Anything after that, anything greater than $0 in sales will increase that amount. So for the range, Y would be everything greater than or equal to $32,500. Alright, because that's the lowest dollar amount you're ever going to make. Anything above that is going to only increase. Okay? So you've seen two different examples here. One involving what we call a discrete situation, where only certain X values will work, and that's why we plotted it using points. And here with the domain range, we'd usually make a list, or if we don't make a list, we got to do something like this, where we're very specific as to which values work for X and which ones work for Y. But a list would be very appropriate for that one. Or you have a situation like this, where it is okay to include things in between your X values that you're using on your scale. Like in this one, I could sell, like I said, $1,250.16. And so you would use a solid line to represent this graph, and so that does give you a true interval notation for your domain and for your range. So each of these different scenarios you're going to have to really think about and decide, okay, well, I'm going to make my graph, I'm going to think about my X and Y intercept, do they help me, do they not help me, as far as figuring out how to label my scales, and then create my graph, deciding if it's discrete or continuous, so dotted or solid. You use your calculator to help you, alright, especially if it's dotted. You're going to need to use that table to help you get those points. And then once you got that figured out, from there you should be able to decide what's an appropriate domain and range that would describe this particular scenario. Okay? Alright, so what I would like for you guys to try to do is work through the even numbered problems on this assignment. Alright, I'm only going to assign the even numbered problems for this one today. You can work with your table partner with any time that's left. Anything not completed is homework, and bring them back tomorrow to discuss. Thank you for working and paying attention. And if you have any questions, you can hold on to them till tomorrow, or I will be back in the morning for tutoring. Actually, yes, okay, I should be back in the morning for tutoring. If I'm not, feel free to talk with one of the other algebra teachers on that hallway. They'd be glad to assist you as well. Thank you.